Thank you. Just a quick clear verification. We're a bit more from the data side of the conversation, even though we're in this track. But just to be aligned, and another short apology, I've prepared for the English presentation. I'll do a quick try to do this in English and hope it would pass okay. So we're DoubleCloud, and I'm here to talk about how to make your investors happy by leveraging your data the right way. I'm a senior solution architect in the company. So of course, what we did was ask ChatGPT, because this is the Data AI Summit, what would make investors happy? And so this is the answer we got, and it's actually pretty nice. So steady growth of company revenues, exceeding financial targets, competitive advantages, separation from competition, path to profitability, financial and decision-making processes that are visible, and positive industry trends with where the company is growing. And we asked DALL-E to create us an image of how investors look like when they're happy, and it created like this suited man with a smiley face on top of a leather chair with a bunch of dollars kind of flying around behind it. Pretty cool. This is what the AI gives us today. But actually, what we were saying is we take those insights, and how we kind of see this is that in order to actually give those success rate years and making our investors happy, where a lot of startups, especially here in the early ecosystem, we're talking about strong financial performance. This is what we want to achieve. We do this by creating better and more accurate, faster data processing, better efficient usage of resources, and more visibility into key performance metrics inside the company, which actually leads us to this increase in revenue and better competitive advantages, faster response in dashboards, or whatever it might be. And essentially, this is the path to glory. So what we do here in this part, right? So we're a data platform that's aiming to be cloud agnostic, scalable, low cost, best in class, open source, end-to-end analytics. So this is our message. This is our idea. So we bring to the table, okay, Apache, Kafka, and ClickHouse, which I'm guessing Kafka, most of you guys have probably heard, but ClickHouse a bit less, and we'll dive into that a bit more. We're bringing some ETL tools and visualizations that are built with high availability, fault tolerance, backups, bring your own talent concepts, kind of features and capabilities to make it secure and cost effective. So that's our main idea. So this is all started, I think, for many of us inside the company when we saw the growth in data tools and trends along the way, which apparently over time you just see yourself getting more and more in this vendor lock-in. A lot of companies really do prefer to be in this place where you have the capability to use the open source tools and not being locked in inside a specific company. Right, so there is this concept of the modern open source data stack. So what we did is we kind of took these best tools and we made them work together, bundled in a clear cut way. So for example, Airbyte, ClickHouse, as I mentioned, Kafka, and we're adding Airflow and dbt these days as well. And the list is growing. So DoubleCloud is a platform, right? So every data architecture for every customer looks something like this, right? So you have your incoming data sources, transactional data sources, something like MongoDB, Postgres, or DynamoDB, whatever it might be. You have some sort of event stream, whether it like self-managed Kafka or MSK, whatever it might be, flowing into a centralized place using different tools, building some sort of data marts or data lakes with bronze, silver, gold layers, flowing into some sort of serving layer that would be faster to serve queries, and presenting that using visualization. So we are trying to tackle that whole flow, providing those open source tools, right? So from the managed Kafka to an Airbyte-based solution to do the data processing, and the ClickHouse itself as a data processing tool itself, and actually a serving layer, which is really good for that. And we'll speak of why ClickHouse is like that, with a pre-baked visualization tool that we provide. So what is ClickHouse? I mentioned it a few times. It's one of the fastest growing analytical databases today. You could see the kind of trajectory here with the GitHub stars and the amounts. It's pretty much surpassing the relevant competition, maybe by the summing them all, and you get to pretty much the same amount of stars. And the idea is it's really aiming to be that really fast, cost-effective data warehouse. And you could see on benchmark.clickhouse.com the kind of list of databases. Every vendor can post the solutions of its own benchmarks on the site and kind of compare the results. So it's really aiming to be this really clear, open place to benchmark your performance. So why is it fast? So first of all, it's a column database. It's not that something really new, but it's something worth mentioning, right? Columnar operation for analytics really increases our performance capabilities by a huge bunch. And with that, it's also doing what's called vector execution, right? So we're talking about seeing the instruction versus single instruction, single data, right? So usually CPU operations perform one operation and one data point and produce one output. What ClickHouse is leveraging are these same instructions, which provide one operation, multiple data points, and provide the same result in a single CPU instruction. So that really improves performance by 10-folds, if not even 100-folds. So ClickHouse, as we can pretty much understand, can scale vertically. That means for the same, just same hardware, just bigger, more memory, storage, and CPU. But what we're all looking for are these horizontal scalable databases, right? So using replicas can help with concurrencies, and shards to add IO operations and increase throughput. So this is usually the different types of way we could perform sharding and replication patterns, something from everything is replicated just to increase our concurrency maybe, or just kind of mixture of shards and replicas. Usually this is how you would see a production environment, and something that's just sharding for spanning more data points. What's happening behind the scene, I think this is worth mentioning a bit, is something that's called LSMT, log structure merge tree. Essentially, the gist of this, again, is just the idea that every table within ClickHouse is indexed with high, and enables us a high insert volume of data into the table, right? So we are keeping the data sorted and indexed, and also not doing anything that hurts the actual performance of inserts into the table. Key companies or known companies that are posted using ClickHouse, the open source version of it, self-managed. So it's eBay, Uber, Spotify, and Cloudflare, as we can see, pretty huge names with really strong technical teams building these solutions for them. So the idea that each one of them kind of brought into the table of sharing their insights here is that eBay said they reduced their overall infrastructure footprint by 90%. That is 10 times less hardware essentially, and built a lot better, stronger integration with their Grafana. This was a use case of kind of log metrics collection infrastructure. Uber had pretty much Elasticsearch replacement, or comparing their performance with that. They improved their something between 3 to 4 times the throughput for writes, as you can see, and just in performance scaled linearly now with the new solution with ClickHouse, 5 times the core speed compared, and reducing or eliminating the single point of failure of their design with ClickHouse compared to Elasticsearch. Spotify, another interesting use case, their A/B experimentation platform, that is, they're trying to see like for each users would have like better traction with different types of playlists or songs being played. This platform was actually built essentially with ClickHouse using petabytes of data and sub-second queries. So again, remarkable results. Cloudflare may be one of the largest infrastructure providers in the cloud zones. They're managed to provide their analytical platform using 8 million requests per second, reducing their mean time to repair, that is, any troubles or issues they had with their downtimes. They managed with that data analytics platform to reduce that and improve their query throughput by 7 times. So again, really impressive results. What I do want to take here is that these are really talented companies with people who could manage their ClickHouse by themselves. So this is where we come in, and we help companies build their ClickHouse data platform. So this is our expertise here. So just to show a quick demonstration of how this kind of works, is that essentially just a simple drag and drop UI with the API based behind the scenes. A few clicks of a button, you get ClickHouse up and running and connectable to perform whatever it is you want. This includes, again, what we said about the backups and high availabilities and everything that you might need or want within your data platform, with the option to perform and bring your own account. That means that we're provisioning the resources within your AWS account or other cloud providers, and essentially providing you also that safe reassurance that it's running within your zone and your hands. Some details about how to connect to ClickHouse. It's something that sounds new, but it has actually quite a lot of traction and a lot of integration from different language libraries, all the way from C# to PHP, and of course Python, and specifically pandas, which I'll show in a second, and the obvious ODBC and JDBC connections to connect to a lot of different databases, and support for native wire protocols as for MySQL and Postgres. So again, really a complete suite of connectivity to different tools and packages. A quick demonstration here. We could dive into this on one-to-one if anybody wishes. Pandas connector, this is how it's called, a quick cute name here. Essentially the idea to run a Python code that's actually really kind of implementing connection for ClickHouse behind the scene, making it a lot simpler for these AI types of operations that we want to build and train our models using pandas with data actually sitting within the data warehouse. Another really cool capability for ClickHouse, which is kind of doing a warehouse combined with a federation query engine. Right, so this enables us to do an integration with other databases, such as this example is MySQL. So you could actually perform your query on your table with a join on another database. So this is actually fetching the data from a road server and doing the join in memory. So pretty cool capabilities, allowing us to provide these sub-second real-time combinations of data points across databases. So to sum up, I think the idea I want to show here is that ClickHouse has a bunch of capabilities that actually enables us, in my flavor, my opinion, is to really tweak and squeeze the capabilities of what could be done with that database. So everything from what's called the merge tree engines, the way that we store the data points, even to like these unique storage engines, so either in-memory tables or embedded RocksDB, which is kind of a key value store, really useful for these kind of streaming places where you want to create a snapshot of the recent key values or something that's streaming from Kafka. And again, connecting directly to Kafka, RabbitMQ, S3 data files, or Mongo, Postgres, and whatnot. Right, so really broad sense of capabilities here. Just to show one of the features we added on top of this ClickHouse is something we called hybrid storage approach. So it's something like S3 peering auditing for storage, that you could move your all data points to a colder storage. We actually provided this offering with the disk-based storage that ClickHouse is aiming to use, with a combination of cloud object storage. So this enables you to define the time to live for different data points inside the table, as the kind of queries here defined. You could define the TTL, and then essentially provide a single query on top of a single table that would join the data points from SSD disk, lower performance disk, or actually S3 types of object storage. Just to kind of show the quick overview here, this was the ClickHouse. I wanted to also show other parts of the platform really quickly. So again, the same type of approach, quickly stinging up Kafka clusters, a few clicks of a button. And another capability, as we said, we're leveraging another open source technology behind the scenes called Airbyte to perform like ETL operations. I would say it's more of a EL type of thing, extracting and loading, or kind of belonging to this paradigm of extract, load, transform. So the Airbyte connectors can connect to different marketing data sources, databases, or data warehouses as well. The idea here is that we could do these kind of connection to these different data sources and transform them to a managed ClickHouse inside our environment and build this data pipeline really simply with kind of even drag and drop, even the local capabilities. Some of the capabilities that we offer are serverless types of operations for the ETL, as well as kind of bring your own account with a dedicated machine on your side if you want to have that security type of operation in mind. So that's for the data transfer. The last piece of bit here is something to do with the DoubleCloud visualization. So again, this is something that we actually built and we're open sourcing ourselves. As we said, we really like the idea of not being vendor locked in. So this is a tool that we built. It actually enables you to do this really nice dashboards with kind of clear drag and drop type of operation, pretty simple. It can connect to not only ClickHouse, but also MySQL, Postgres, CSV files, or BigQuery, and we're adding more and more support for more graphs and more connectors. This is actually currently a free part of the product, so we could use this and not even think about anything else. And as well, we're providing soon some advanced embedding capabilities, which we see that are highly in requirements these days in the markets for everything on the data types of platform customers like yourselves are building. So this is us. I'd like to say thank you. 2 points I wanted to just mention here in the end, on spot on the timing here. You could use the system with free trials, no credit card needed to just explore, and just reach out to us for some conversations on data while we kind of eat some burgers with you. So thank you so much for being here. And if you have any questions, I'll take them later in the Q&A. Thank you.